Okay, so people should now be able to see, I've got kind of a PowerPoint up. I'm just going to zoom in a little bit. So hopefully people can see that. And I'm just going to go ahead and start presenting. So this session is meant to be very informal. Please stop me at any point throughout to ask questions. If you want me to, go deeper in explaining something, please feel free to do so. I believe everyone's audio should work if they want to speak. There's also chat available as well. If you look on the left sidebar, you will see the chat icon. And so you can type questions, you can speak those questions, anything that you need to do to kind of get my attention. I want this session to be interactive. So please make it so. If there's anything I can do to explain material in more depth or make it, more easier to understand, I'm happy to do so. But this is kind of in a Concourse Development 101 session. The idea here is for us to really just kind of look at some high level concepts and look at the code base and really get a sense of how you can dive into the code base and understand what's happening and then start to make some changes. And so this is the agenda that I have laid out. We have, an hour and a half reserved. How much of that time we take really just depends on how interactive the session is. I can get through this stuff pretty quickly, but really if some of these things require more explanation, then, I'm happy to do that. And that'll really make the session a lot more rich. So it's going to be driven by the participants and people kind of telling me what I need to spend more time on. But at a high level, what we want to do is focus on some key concepts. Then we're going to talk about the actual project structure. So if you look at the Concourse code base, there are a ton of different projects and folders and files. And really, I just want to give a sense of how all those things fit together. Then I'm actually going to dive into the code. And I'm going to walk through 3 different paths to give people an intro on how the pieces fit together and really show what's going on. We're going to talk about what happens when you start Concourse server. We're going to talk about what happens when you write data. And then we're going to talk about what happens when you read data. Then after that, I want to give just a brief talk about unit testing. I think unit testing is very important, and we do a lot of it with the Concourse code. And because it's so important, we've taken a lot of care to make sure that it's very easy to do. So I definitely want to give an intro to that as well. So that's the high level plan. Before I dive into it, does anyone have any questions or suggestions for anything that they want me to add or maybe consider that's not on here? You can certainly echo those things now, but if as we get into it, more things come to mind, please feel free to, again, chat those to me on Google Hangouts, or if your mic is working and you can contribute in that way, please feel free to do so. So before I dive into the project structure, let's just talk about, Concourse and what it is and what the goals of the project are. So the way we describe Concourse is that it's a self-tuning database that enables live analytics for live streams of operational data. Okay. And I'm sorry, that's actually a typo. That should actually be large streams, but it could also be live streams. But live analytics for large streams of operational data. And, if you do any studying about databases, one concept that you'll come across is this notion that the need for transactions, which is the ability to have ACID transactions to store data, and the need for analytics, which is the need to be able to get insight from data that's being stored. There's tension in being able to do those things at the same time. So you typically have what are called OLTP databases. Those are called online transaction processing databases. And then you have OLAP databases. Those are online analytics processing databases. That's a very broad distinction in how databases are classified. There's been a movement as of late with just the emergence of data from different sources and businesses and different people needing the ability to do all sorts of analytics. And I'm sorry, someone just sent me a message. So I think some people are having trouble getting the Hangout. I sent the link to the Hangout, so I think people should be good on that there. So I'm just going to continue on. So as I was saying before, there's been this desire in recent years to be able to have ACID transactions, but also be able to do live analytics on that data as well. And so Concourse is a database that is built in that spirit, really wanting to allow developers to build tools that require ACID transactions, but also would benefit from the ability to get live insight into the data that's being stored by those tools. So those are some of the high-level goals of Concourse. When we talk about key concepts, really to understand the data model, Concourse is a non-relational database. I really don't like the term NoSQL because I think it is a misnomer. You can classify Concourse as a NoSQL database because it does not use SQL as the query language. It is also non-relational because it does not adhere to the relational model. I'd like to describe Concourse as a document graph database. Its data model is schemaless and very simple. And unlike most document databases, it also has the ability to handle relationships and connections among data and display that and handle that in a very first-class way. But when we think about just very key concepts for understanding the data model, the top level of organization and structure is an environment. And an environment is similar to if you have a background in Oracle, if you've ever used that, it's called a schema. If you ever use MySQL or Postgres, it's what they call a database. If you are familiar with MongoDB, it's what they also call a database. If you're familiar with Cassandra, it's what they call a key space. An environment is sort of the top level of separation for data. So uses for an environment, typically you would store each application's data in its own separate environment. If you wanted to have an application that featured multi-tenancy, sometimes you may use a separate environment to store data for each tenant. So that's kind of what the notion of an environment in Concourse is. There is no way to query across environments. So data that's stored in one environment is not accessible to data in other environments. So there's a very clean and hard separation there. Then we get to a record, right? So now this is really kind of the data model that most people are familiar with. So a record is, again, analogous to, in a relational database, it's analogous to a row. In MongoDB, it's analogous to a document. Those are kind of other names you'd hear for it. We choose to call it a record, but you can call it a document. You can call it a row if you want to visualize it as a table. Again, this is a non-relational model, so we don't have tables, but that's what a record is. Now, the difference here that you'll notice about the Concourse data model is that typically other databases will go from the top level sort of environment, database, key space, or schema, that notion, and then they'll have another level of organization like a table, or in MongoDB, it's called a collection. Those things are basically ways for you to organize data and that's logically related. So you may have a table or a collection for all of your user data in your application. You may have a table or collection for all of your bank transaction data. Concourse has no such thing. Every record sort of exists in a large universe, and it's all just there. It's not separated into tables or collections. Every record is there. And that's somewhat why we consider this to be a document graph model, is because we just like to think of the world as there are a bunch of records that have connections, and they have, different attributes, right? But really they all exist in the same universe. So there's really no need to impose any additional structure, above the level of a record. When you dig into a record, you have a key, or sometimes it's referred to as a field. Really, that's just the label of an attribute, right? So that's the name, the user's name, their age, their email address, or for a bank account, like the account number. Basically, if you think of in a relational model, it's the name of the column, the label for the column, or in MongoDB, it's the attribute name or the field name. Same thing in Concourse. And then under that is our values. So fields or keys, they store values. So in each record, you can have a key that maps to one or more values. The only restriction on values is that you cannot store duplicates. So you can't store the same value multiple times for a field in a record, right? But again, this is a schemaless database. All the structure of one record in no way imposes any constraints on the structure of another record. What you do to one record does not mean you have to do it to any other record. So that's the data model at a very high level. Now I want to actually dig into the project structure, because I think that is important to look at. So if you check out the Concourse code base and you just kind of do an ls on the root of the file system where the code base is housed, you'll see a lot of stuff. There are a lot of directories, what seem to be a lot of different projects. There are a lot of different files. And this can be overwhelming because if you're wondering where to start contributing, where do you begin? I mean, do you start with one of the drivers? Do you start with the server? Do you start with the shell? It gets very complicated. So one of the things I want to do is just kind of visually demonstrate how that's broken down. So sort of at the top level here, where you see Concourse shell. Concourse shell is an example of an application that uses Concourse. So if we back up for a moment, Concourse is it's a database that exposes an API. So just like MySQL or any other database has a server component that has logic to store data and index the data and serve requests, there's ultimately an API that you use in your application. And for relational databases, that's SQL. The structured query language is the API to access a relational database. Now, you may use some ORM like Hibernate or JDBC if you're from a relational background. And sometimes that is what's used to interact with the underlying database. But again, these are all just different APIs. And APIs are just abstraction layers to help you interact with the power that the server provides. And so what happens is that when you build an application, you incorporate that API and it allows you to do stuff. Well, Concourse shell or cache, as it's referred to in a lot of places, that's just an application. And it uses the Concourse API, and I'm going to demonstrate exactly how it does that. And so that sits on top of the different drivers, right? So, cache is an application. You could take the Concourse API and build your own application, and it could work in a similar way. Cache just happens to be a command line based, what's called a REPL, a read eval print loop, that really just allows you to interact with Concourse, and we ship it with the server, and it's sort of built in that way. But what cache depends on is the Java driver. And just like there is a Java driver, there's a driver for Ruby, and there's a driver for PHP, and one for Python as well. And, having drivers, right? Again, the drivers are just implementations of the API for different languages. So if you're a Java developer, you can take the Java driver, put it in your application, and interact with a Concourse server. Same thing with a Ruby application or a Python one or a PHP one. Concourse shell just happens to be written in Java, so we use the Java driver. But you could easily have written Concourse shell in Ruby and use the Ruby driver. Underneath the drivers, right? So it's kind of clear, right? We have drivers, those are the clients, and then we have Concourse server. But then there's some stuff in the middle, right? Those orange and green boxes. And I want to pay attention to the orange box because I think the hardest part for most people to really grasp when they think about Concourse and how this code base is structured is how is it that they can type something in Concourse shell or use the API in their application, and then that stuff gets to the server, right? That's probably the hardest thing for people to kind of grasp, right? Well, the orange piece, the interface, is really what makes that happen, and that's thrift. If anywhere in the code base you see a reference to thrift or this directory is now called the interface directory. It was previously called the thrift directory or the thrift API directory. Thrift is an amazing open source project. It's produced by the Apache Software Foundation. And all Thrift does is it automates the process of writing code to allow a client to talk to a server. And that's what we refer to as RPC, which is a remote procedure call. So if you think about the way your web browser works, when you type in a web page on your client browser, right, it goes to some server, right? It does DNS routing and it goes to that server. And that server sends the code, right, the HTML, the CSS, the JavaScript, back to your browser to render that, right? So that's an example of a client-server communication architecture, right? Again, your browser being the client makes a request, it goes across a socket and it goes to the server, it gets that information. Well, if you're on a web page in 2016, then it's probably using some form of AJAX. And what happens there again is that your browser, maybe you click a button, you're in Gmail and you click refresh to see if there are new email messages. You click a button, your browser, the client makes a request to the server. It does, again, the equivalent of an RPC call for websites, which is what AJAX is essentially. It tells the server, hey, do this thing, right? Run this routine. Tell me if this user has more email. And the server gives a response to the client, and the client handles that response. That's exactly what happens with Concourse. And when we talk about the relationship between the drivers, which are the clients, and Concourse server. And Thrift is really the layer that coordinates all that. And it's an awesome open source library because it makes it so that we don't have to write any RPC code ourselves. We can simply define an interface of methods that both the client must know about and the server must know about, and Thrift just takes care of the rest, okay? Alongside Thrift, you have some other things like the Concourse CLI project, the Concourse import project, the Concourse plugin core. Those are less important for what we're going to talk about today. But the point of those things they are just libraries that do not depend on Thrift. But they, in some ways, provide functionality that Concourse server depends on. So they don't depend on Thrift. They don't use the drivers themselves. They interact with Concourse in different ways, if they interact with it at all, or they're just kind of standard libraries that allow Concourse server to do some different things. That's a more advanced topic that we're not going to dig into today. And the last piece is just all the testing directories. So there's the integration testing directory. There is the unit test core, there are bash tests, upgrade tests. We have a lot of tests because testing is important, and I'll dive into that some more when we get to the testing section. But that's kind of, the most talking that I want to do without anyone sort of interrupting me to ask questions. So I see that we've got some more people that have joined. I know there are some emails going around about, I think some people may be having trouble accessing the Hangout version of this. If anyone's watching and they're able to do so, please send a message to the Concourse Devs user group, just to kind of let people know how to access it. But what I'm going to do here is kind of actually dive into code. And if people are able to use the chat function of Google Hangouts to send questions, please do so. If that's not working for anybody, you can email me. I've got my phone. I'll be able to see email messages that come through, because I really want to be able to allow people to ask questions as they have them, and I talk through some of this stuff. So the first thing I'm going to show is starting Concourse. What happens, right? What is the magic that happens when you actually launch the server application? So here's just an overview, and I'm going to talk through these things individually as I walk through the code. But what happens at a high level, obviously we launch the JVM, the Java Virtual Machine. We run some upgrade tasks, which I'll explain a bit more in detail. We initialize JMX. I'll talk about that some more. We start the engines. We start an HTTP server. And then we start the RPC layer, which is what I was just talking about with Thrift. And I'm going to actually walk through the code base to show each of these things as it happens. So I'm going to stop sharing the presentation, and I'm going to share a different screen. So if you'll just give me 1 second. Okay, I think this is the one that I want to share. Okay, let's see. No, that's not the one I want to share, but we will make it work. So I'm in Eclipse, and Eclipse is an awesome tool. For those that don't know, like Eclipse shortcuts, I'll kind of talk through some of what I do to hopefully demystify that for people. But I want to open up the Concourse server.java class. And so what I'm going to simply do is, I have a Mac, but I think the equivalent on Windows is Control-Shift-T. On a Mac, it's Command-Shift-T. And that's going to bring up this dialog that allows me to basically type in the name of the class that I want, so I don't have to go searching around the class hierarchy. So I'm just going to type Concourse server, because that's the class that we're going to look at. Okay, so I put some breakpoints in the code, and I'm going to launch this in debug mode so that we can actually step through and talk about things together. So in Eclipse, if you want to debug something, this little icon here that has the symbol of a bug, and it appears that I already have a server instance running, though I don't believe that to be true. That allows you to debug the code, right? So you can sort of pause execution, inspect the state of variables, figure out what variables are on the stack. It's a very, very cool way to kind of run the code if you're trying to figure things out. So I'm going to start Concourse in debug mode, and you'll notice what happens is this debug window, this debug view comes up, and I have a breakpoint here. So we're in the main method of Concourse server. So just like any Java application, when you run Concourse server, whether you run that from Eclipse or you run it from the command line, ultimately what happens is this Concourse server .main method gets called, and that is the entry point into the application. And so the first thing we do here is we run the latest upgrade tasks. And what this is really about is we have an upgrade framework in place. So when users upgrade Concourse server, right, when they get the new binary installer and they run that, they'll get the latest jars and the latest code. But it's possible that we've done some things to change how data is stored on disk. So for instance, from version 0.3, between version 0.3 and 0.4, we changed some things with how data was actually laid out on disk. And so that's something we don't want people to do manually. We don't want to say, hey, you've got data on disk, do run this thing and possibly corrupt your data or take a backup. That gets very complicated. So what we have in place is a mechanism for a Concourse server to automatically, when it starts up, to understand if it needs to do any upgrades to the data on disk. And if so, take a backup, upgrade the data, and make sure that that's all done atomically and consistently so we don't corrupt anyone's data. So that's the first thing there. This doesn't happen often, but it's the first thing that the server runs, because before we get into all the logic, we want to make sure that we're running with not only the latest version of the code, but the data that's stored on disk is represented in the latest format. So then after we run data on disk, and I'm just going to step through. So I'm actually just going to, again, if you've never used the debug mode in Eclipse, this allows me to step over a line of execution, which means I just let it execute. This button here will allow me to step into it, which means I actually go into that particular method and inspect, again, like I can go line by line and inspect the state of execution. So this is where, this line here, we just check to make sure that you've got a large enough heap size. We rely on some kind of JMX, built-in Java introspection tools to do that, to inspect the heap size. So that's pretty basic stuff there. And then here we actually create an instance of the Concourse server class. And let's actually dig into that method and see what happens. So I'm going to set a breakpoint here just to make sure that we can get back to where we were. But let's actually step into this method and inspect what goes on. So, it defers to another instance of this. So it calls another instance of the create method, specifying these kind of static factory variables for the client port, which I can inspect and see is just the standard 1717, the buffer directory, which I can actually see what that is, and the database directory. These values come from the concourse.preps file. So if we wanted to change these values, that's how we would do so. We would just change it in the concourse.preps file. The reason that there are two methods, the reason that there's this method that explicitly takes those values as parameters is for unit testing. If we want to write a unit test and we don't want to have to deal with a preps file just for the purpose of a unit test, we can create an instance of Concourse server and explicitly give it the values that we want. So what happens, this line here, this uses the Juice framework, which is provided by Google. It creates what's called an injector. That is, if anything is sort of black magic in this code base, that is black magic. That has a lot to do with bytecode manipulation. It's a very, very advanced topic, and I'm not going to dig into the details. But the purpose of that line of code is just that it alters the code base to add code to it that is necessary, but we don't want developers to have to write that for every method. So in particular, an example is that throwing exceptions that happen throughout the code. Whenever an exception is thrown, we want to handle that in a very special way before we propagate that exception to the client. But if we had to write that exception handling logic for every method that Concourse server has, that would be tedious and error prone. So we use the Juice library, and it's spelled with a G, but it's pronounced Juice. We use the Juice library to sort of take the code base and automatically manipulate the bytecode that's generated to add the logic that we want. Again, that's a very advanced topic, and I won't dig into the details. But basically what happens when we create an instance of the server is we get, Juice does its thing, and then we initialize it. So I'm going to go into the initialization method. And what happens when we do initialization, and I'm just going to kind of expand my window a little bit just so people can hopefully see a bit more. But what happens is the first thing we do is we want to check that what is configured to be the data location for the buffer and what's configured to be the data location for the database are not the same. That's the first thing we do. Again, we just check some more basic preconditions. We do some checking on the name of the default environment. I'm not going to really dig into that, but again, these are just basic checks that we do to make sure that the server instance is going to be, it's going to run in a good state. Then what we do is we make the directories for everything we need. So one of the things that frustrates me the most about a lot of other databases is that you download the installer, you install it, and you're like, all right, I'm so ready to use this and try it out. And you start it, and the first error you get is data directory does not exist. You know, if you try to start Mongo from scratch, 9 times out of 10, you're going to get that error. And so that's really frustrating because, in my opinion, anytime a user runs into a roadblock, no matter how big or how small when using software, that dampens their enthusiasm for using that software, and it risks losing them as a user, right? And you don't want to sort of have roadblocks thrown up early on. So with Concourse, if there's a directory, we try to make it. If you say, hey, this is where I want to store my data, and that data does not exist, we try to make the directory. And you know, this method here, I'm just going to quickly take a look at it. It has logic to, you know, basically only create the directory if it doesn't exist. So if the directory does exist and it has data, it's not going to erase it or delete it or anything like that. But we just go through to make sure that the directories we need to store data for the buffer and the database both exist. We lock those directories, and the purpose of locking it is so that if you have multiple Concourse server instances running on the same box, you don't accidentally point those to the same data directories and they're both kind of, you know, using those files and writing to those files. And then the rest of this logic is how we initialize the RPC interface, right? So everything with Thrift, so this sort of T server socket, that is from the Thrift library. We create, basically what this does is it creates a Thrift RPC server, and that Thrift RPC server is responsible for listening to requests from clients and then processing those requests and then routing those to the appropriate methods in Concourse server. And I'm going to show exactly what I mean by that. I promise. I know it's kind of vague now, but I'm going to show exactly what I mean by that. So I'm just going to, again, just kind of, you know, step over a lot of this stuff because it's stuff that we'll never have to write again. It's just setting up a Thrift server. Then we set up some, and so what you'll notice here is a lot of stuff happened when I just kind of stepped over that. So what happened was we actually, and here, let me get my code base together. So what we did is we were in the initialization method, and we kind of finished that method. And what happened is we got here and we loaded the default engine. In engines, there is one engine per environment. And so loading the default engine is loading the engine for the default environment. And so what happens in that method is we actually go through and there's a lot of misdirection sometimes. We sanitize the name of the environment, then we actually do the work to get the engine. And we just create a new instance of the engine class. And if I actually look into that code, right, when we create an instance of the engine class, what happens, again, more misdirection, but you just kind of follow the chain of logic. What we do is we create a thread to transport data from the buffer in the background. We create a place to store transactions. We create what's called an inventory, and the inventory is just a list of all the records that exist. And we, you know, set the thread name prefix. And what that has the effect of doing is once we did that, you'll notice these log messages. We had a lot of stuff about loading information, and, you know, you'll see that it's telling us that the buffer is configured to store information here. It's loading buffer content. So a lot of stuff just happened, but that's really why it happened, because we got to the point where we created an engine once we were initializing the Concourse server instance. So I know that was a lot. Just want to check in. Does anyone have any questions or anything before I continue to kind of dive into stuff? Okay, if not, I'm going to go back to the main method and just kind of continue debugging. And again, I see there people are emailing, getting people the link, so definitely appreciate that. If anyone missed earlier parts of this session, it will be on YouTube, so people can refer back to it. Again, feel free to type questions in the chat box or send emails, and I'll be happy to answer those. But once we have our server instance, and we're just going to step back up to the main method, we've created an instance of the server and all of its dependencies. Then we're going to this registering in MX Beam. That is basically what makes JMX possible. JMX stands for Java Management Extensions, and that's really a protocol that Java provides that allows people to interact with a long-running Java process and to inspect sort of the state of the heap, what's going on with garbage collection. Certain methods may be provided, what are called management methods. You can provide some of those. So we just set this up to make it so the Concourse server can benefit from that. Then the fun stuff actually happens. Then we want to actually start the server. And we do that in a separate thread. And the reason we start the server in a separate thread is because when you start the server, it blocks the thread, the calling thread is blocked. And it blocks basically waiting for connections and processing those connections. So we have to start those we have to do that in a separate thread, because after we start the server, there's more work that we want to do. The work that we want to do after starting the server is we want to create a shutdown hook. And that shutdown hook basically, if you're unfamiliar with shutdown hooks in Java, that's basically a mechanism where you can say, hey, if the Java process dies in any way that's considered normal, so that means that the kill int signal is sent to the server, or someone just does a hard stop on the process from Eclipse. Basically anything other than a kill 9 will execute the shutdown hook. So that's sort of a last opportunity to execute some code to clean up the state of the file system or whatever else, whatever other resources may have been in use before the Java application dies. And so we set up a shutdown hook. We actually add a mechanism, what's called a shutdown listen report. So the proper way to shut down Concourse server is that we make a connection to another port that we listen on, and that sends a signal to shut down. This is where we have the shutdown hook, and we do some stuff to do natural language parsing as well. So that's the stuff that we do after the server started in the background. But the fun that actually happens when the server starts is this line of code right here. So I'm just going to press play to get to that point. So you'll notice, like, this line of code that to display the welcome banner, that executes before we start, and you'll see that that's printed on my console down here. And then when we're ready to start executing this line of code for the server, I'm just going to go into this method and make sure that we can inspect what's going on. So I'm going to get to this point, and what happens is that we start every engine that we've loaded. So right now, the only engines that we've loaded is the one for the default environment. There's typically only one engine loaded when the server starts, and that's the default one. And so what we do is we go through all those and we start the engines. So we're going to actually step through, and I'm going to step into this method to start the engine. And you'll notice that it first checks to see that the engine is not running. And again, that engine's already going to be running because once we load the default engine, that's the one that is started first, right? So all this stuff about starting the buffer and all that stuff, all that already happened, right? Because you can see here all the stuff that we've loaded, and that's from the default engine starting, right? So we quickly are done with that. We start the HTTP server. The HTTP server is a new feature that's been added for the upcoming release. It's basically another way to interact with Concourse server is using a REST API, and the HTTP server is what powers that. We will print this line to the console, and then this variable here is bound to our Thrift RPC server. And what we're going to do is we're just going to serve. And you'll notice that execution has been blocked, right? I can't do anything else because now Concourse server is in a state of listening for requests so that it can process that. So that's what happens when we start the server. I know that's a lot, and that's a code path that doesn't really ever change much. So that's not something that people will really have to interact with. But what I'm going to do now is show what happens when we write data. And again, if people have questions, feel free to type them into the chat or send an email to the Concourse devs email list, and I'm happy to answer those. Okay, so just gonna again bring up the slideshow. Gonna bring that up. So again, just to review what we talked about when we start Concourse, we launch the JVM, we run some upgrade tasks, we initialize a bunch of things, and we start the engines, the HTTP server, and the RPC server. The next thing we're going to talk about is what happens when you write data. And this is where it's going to really become clear how Thrift plays a role in this process. So we're going to show how data goes from the client, and it gets transported via Thrift to Concourse server. Then it gets processed by the engine to be stored in the buffer, and then eventually get transported to the database. Okay? So I'm going to, again, start sharing my, I'm going to share my Eclipse again. Just give me a second. Okay, so I'm in Eclipse again, and what I'm going to do now is I'm going to launch Concourse shell in debug mode, okay? Again, if you recall earlier, Concourse shell is just an application that uses the Java driver. So I'm gonna demonstrate how we get from an application, getting input into that application, and then sending that input to the Java driver, and then the Java driver sends that data to Concourse server via Thrift. Okay, so in debug mode, I'm going to launch the shell. If you pay attention to my console down here, let's make sure I have the right one. Here, 1 second, let me do that again. So I'm gonna, again, launch cache. It's gonna make my window smaller so I can see what's going on. All right, so what I'm gonna do, again, I'm gonna restart Concourse because I think Eclipse got a little confused on some things. So gonna start Concourse in debug mode, but I'm not gonna step through everything. I'm just gonna let it rip. Sometimes when you run Eclipse in debug mode and have things pause for too long, Eclipse kind of gets confused. Okay, so Concourse is running. I'm gonna launch cache. Okay, and so now you'll see I have an instance of Concourse shell running in my debugger, right? So I can type anything, and it'll just work. But the point is, I'll be able to inspect what happens. Okay. So again, remember, this is just an application. Okay. So I'm going to write some data, and I'm going to add a value. I'm going to add the value 2000 in the foo field in record 17. So this means add foo is 2000 in record 17. So that's what I'm going to do. Okay. I'm just going to go ahead and press enter. And what you'll notice in my debugger, I'm now debugging Concourse shell, right? And what I hit is this evaluate method. Concourse shell ultimately, when you're running it in this mode, everything goes to the evaluate method. And so you can see the line of input that I typed. The first thing that happens is we do this thing where we handle short syntax. So the way that Concourse shell actually works is that we embed a Groovy interpreter into the application. So the actual logic of handling the code that you type is handled by Groovy. So we don't have to write custom logic. We don't have to write basically a new programming language. So you can actually type in full-fledged Groovy programs into Concourse shell, and it will more or less work. And so since all of this code is handled by Groovy, you've got to adhere to Groovy syntax and Groovy conventions, which means that you've got to, if you're calling a method from the Concourse API, you've got to have the Concourse API bound to a variable, and you've got to invoke that variable explicitly. Well, that can sort of be a pain, right? If we had to type concourse.method and then supply the arguments, that is just like having to type concourse every time we want to call a method on the Concourse API is kind of tedious, right? The fact that we're in Concourse shell implies that we want to call methods on the Concourse API. So the notion of short syntax is that we can type a method name without specifying the Concourse variable. And when we handle the short syntax, we'll behind the scenes prepend the Concourse variable. So I'll show what that means. So you'll see my line of input was calling the add method with these parameters. Well, when I handle short syntax, my input is now concourse.add, right? And so that's what I mean, where that's actually what Groovy would want you to type, but that's tedious. So we allow people to omit that, but behind the scenes, we'll go and add it for them, okay? And we then bind a bunch of variables to the Groovy interpreter. So the one in particular that's relevant is this line here. We bind to the concourse variable that Groovy knows about this concourse connection, right? So this value here, this concourse object here, is a connection to Concourse server, right? It is an instance of the Java driver that is connected to the Concourse server instance that I have running in Eclipse. You can see that it's connected to localhost at 1717 as the admin user, right? And so we bind that to what Groovy knows to be the Concourse variable, and we bind a bunch of we will bind a bunch of other things as well. But the point is, we get to a point where all this logic to sort of bind stuff, it's not really relevant at this point. And we get to the place where we actually want to evaluate it. So I'm just going to press play and go there. So we're at the point where we actually want to evaluate the input. So again, this is the input that Groovy is going to know about. And we actually tell the Groovy interpreter to evaluate that input. And so again, this is Groovy. I'm not an expert on the internals of Groovy, but basically what happens is that the Groovy interpreter has a binding to the Concourse driver API. It invokes the add method on that driver API, and that gets called. And so we're going to see that. So I'm going to press play, and what's going to happen is that the Concourse driver, Java driver, is going to come up, and then we're going to inspect that. We're going to start our inspection there. So I'm going to press play. And what happens is you'll notice that this concourse.java came up. And so concourse.java is it's in the Concourse driver Java project. And it, just look, if I look at the class hierarchy, it has a lot of methods. So all the Concourse methods, this is the API, right? So they are the add methods, the browse methods, so forth and so on. This is where they all live, in the concourse.java class, right? But concourse.java doesn't actually do any work. All it does is route methods. It takes parameters for specific API methods, and it routes them via thrift to Concourse server, okay? And I'm going to show exactly what I mean by that. So you'll notice if we go back to our debug mode, we were in Concourse shell, and we typed add foo, it's 2017, and Concourse shell passed that off to Groovy, and Groovy is evaluating that line of code. So it calls the concourse.add method. And so that's why we're in the concourse.java class now, okay? And we're going to actually go to the add method in question, which is this one right here. And this is where I want to talk a little bit about the thrift API. So if anyone looks at, if they go to the interface directory and they look at the file concourse.thrift, there are a bunch of methods, right? And they're all named things like add key value record, add key value records, browse key time. They're all horribly named, and there's a reason for that. Java is nice in that it lets you do what's called method overloading. So for the add method, we have, multiple methods that are called add, and they take different parameters. And Java is able to disambiguate what we mean when we call add based on the parameters, based on the number and type of parameters that we provide. Well, every language doesn't support that. In particular, dynamically typed languages that are typically interpreted aren't really good at supporting that. So Thrift has to support the lowest common denominator of features across languages. So Thrift does not support method overloading. So we have to name each of the Thrift methods after its function and the parameters that it takes. So this method here, add key value record, is a Thrift method that is for the add function for the parameters that are a key, a value, and a record, right? If we, for instance, had called this method, right, where if we provided a key, a value, and multiple records, then it would call this Thrift method here, add key value records. The records, as opposed to record, implies that it takes multiple ones, okay? But the point is, the Java driver is saying, okay, you've called the add method and you've supplied these parameters. What that actually means is that I should send this data to the add key value record that's defined on the Thrift API. And remember, Thrift is the API that both the client and the server speak to each other. So that's the API that they know about. Thrift is not meant for end users. So if you are using Concourse in your application, you should never call Thrift methods directly, okay? Thrift is really just the API between the client and the server, okay? And so it's saying I need to call the add key value record method, the Thrift method. I'm going to give it the key, and I'm going to give it the value, but I'm going to do this convert Java to Thrift, right? What does that mean? So let's actually dig into that method and see what it means, okay? What I'm going to do is I'm going to add a breakpoint here so that we actually can see it execute. So I'm just going to press play, and we get to the Java to Thrift method in the convert class. And the reason we have to do a conversion on values is because Thrift has a very defined set of data types that it can support, and they're all primitives. But the thing about values in Concourse is that they can be any Java object. They can be primitives like strings or integers, or they can be maps, or they can be custom objects. So we had to convert those to a format that Thrift can understand, and that we can then reconstruct once we get to the server. Basically, because Thrift can't just handle any generic or apps or arbitrary Java object. So what we do is we take the object, in this case it's 2000, and we inspect its type. In this case, we've got an integer. And this is just a long if-else block. And we serialize that object to binary. So for an integer, it takes 4 bytes. And again, we construct a byte buffer. We give it that integer, so you can see like this is literally just a byte buffer, and we specify the type, and that's all a T object is. A T object is just a binary representation of a Java object and a field that specifies the type that the Java object had. So we do that, and we rewind it. We create a T object, and we return that, and we're back here to the calling context. But again, we're going to call this add key value record. We're going to call that method. We're going to give it the key. We're going to give it the T object that we created from converting the Java object. We're going to give it the record, and we're going to give it the credentials. The credentials are basically, once we log in and we authenticate, we get what's called an access token, so that we don't have to specify a username and password on every method invocation. We're gonna give it a transaction token. If we were in the middle of a transaction, then this transaction token would tell Concourse server how to store the data, and then we're going to give it the name of the environment that we're using. Okay, so that gets passed via Thrift. Now I'm going to press play again, and the next place we're going to end up is in Concourse server, and the method we're going to be in is the method called add key value record. So I'm going to press play. And oh, look where we are. We are in the Concourse server class. Okay. And again, remember, Concourse server is a different process. It's a different process from the Concourse shell process. You can see I've got 2 processes down here. Here's my shell process. Here's my server process. Okay. And this is the power of RPC. All right. We can call, these processes don't even have to be on the same machine. Theoretically, Concourse server should be on a different machine, right? But the method, Thrift will take the data and transmit it across the wire, and we'll end up in this code path on the remote machine. And so in the add key value record method, what happens is that Concourse is going to check the access. So it's going to take a look at our access token and the transaction token we provided. In this case, we haven't provided one because we're not in a transaction. It's going to take a look at those things. It's going to, again, check to see if we're trying to specify a link. If so, it's going to perform some validation. That's not relevant here. If all that's cool, then it's going to execute this block of logic here. It's going to get the appropriate store. So when we speak about a store in Concourse parlance, that's really just the place that data is stored and handled. So the common examples of that are, we have the buffer and we have the database. Those are 2 instances of a store. If we're in a transaction, then the transaction itself is a store. It stores data in a different place, right? So it's going to say, hey, given the transaction token that I've been provided and the name of the environment, return the appropriate store, okay? And all that does is it looks to see if the transaction token is null. If there is a transaction token, look and get the appropriate store for that. Otherwise, get the engine that corresponds to the name of the environment that I've been provided. That's all it does, okay? It does that, and it calls the add method on the store that's returned, okay? So I'm going to press play, and we're actually going to go into the add method of the engine. Because, again, in this case, we're not using a transaction, so the engine is the store that we care about. And the engine, it's what's called a buffered store. And a buffered store is essentially a store that has two substores. And the two substores of the engine are the buffer and the destination, which is the database. Okay, and I'm happy to explain more about why why there's a buffer and database, and there are two stores. That's a little more advanced, but happy to answer questions about that, time permitting. Okay, but since we've only got 20 minutes left, I want to just go ahead and step through. So we're in the add method of the engine. So just to review, we started off in Concourse shell. We typed this line of code here. That went to the Java driver. The Java driver said, okay, I need to call the add key value record method from the Thrift API. That got transmitted via Thrift to Concourse server. And the add key value record method implementation in Concourse server, we sort of recognized based on the credentials that were passed in, the name of the environment, and the lack of a transaction token, what engine would be needed to process the request for that data. And now we're in the add method of that engine. So what we do here is all of this stuff here, grabbing tokens, all this is for grabbing the appropriate locks. So Concourse uses something called just-in-time locking. And there are blog posts about that, and I'm happy to answer questions about that as well offline or at a later date. But what we have to do is we have to lock basically the foo field in record 17. We have to prevent anyone from reading or writing data there, because that's where we want to write data. We also have to prevent, we have to get a write lock on that particular piece. We also have to get a shared write lock on the entire record as well. And the purpose of the shared write lock is to prevent other people, it's to allow other writers to write to different fields, but to prevent sort of other things that can mutate that record across fields. Then we need to get a range lock. A range lock is to protect queries. So if anyone were doing a query where they were trying to select all the records that had a value for foo that was greater than 13, then potentially would be included in that. So since we're writing that data, we need to lock that sort of query out, right? But if anyone was looking for data that was less than 13, then that query would not be affected by this write. So that query would not be affected by this range lock. But we get those locks and we grab them, and then we do this add unsafe. And usually when you see a method with unsafe on its name in Concourse, what that simply means is that it's an internal method first and foremost, but it's unsafe because it doesn't do locking, right? And we just add the unsafe appendix to make sure that it is clear that this method should be used with caution. So you would want to hover over it and read the documentation. And you can see that it does this without grabbing any locks, okay? So we're gonna go into the add unsafe method. So I'm gonna press play and we get here. And what this does is it calls a super, the add method in the super class. And the engine, just gonna go up for a second. The engine extends this buffered store class, okay? And there's the buffer store, there's documentation. It basically says it holds data in limbo, and limbo is just a nice name for a store that is not backed by anything on disk. And it holds the data in limbo before it batch commits it to a permanent store. And if you think about the engine, which has a buffer in the database, the buffer is an implementation of limbo. So I'm actually just gonna pull up that class hierarchy. So if I pull up limbo and I look at its class hierarchy, the buffer is an implementation of that. The buffer is a limbo store, and the database itself, if I pull up that class, the database is a permanent store, okay? So what the engine does, the engine is an example of a buffered store, it initially puts data in the buffer, which is a limbo, and it batch commits that to the database, which is a permanent store. Okay, so we defer to the implementation of the add method in the superclass. So I'm going to play and we're going to go there. So this is in the buffered store. We're in that add method. And this will validate the right data. That basically just checks to make sure that the key has the appropriate characters and things like that. The value isn't empty. And we generate what's called a write. And a write is a representation of a modification. So it's here we're trying to add foo is 2000 in record 17, and this corresponds to the timestamp. Again, this is how we started off in Concourse shell. This is ultimately how the data looks to Concourse server, right? And to the engine, right? So we generate that write and we verify it. So Concourse doesn't allow you to store the same data in the same value for a single field in a single record, right? So we have to verify that the value 2000 does not already exist for record 17 and the key in the foo field. Okay, so we verify that. So I'm just going to press play, and we go to the verify method, and this kind of touches on the read path a bit. So in the interest of time, I'm just going to combine what that looks like. So when we do a read, right, and the write path has an implicit read, what the verify method is doing, again, we're in the buffered store. It takes the key and it takes the value. And this line of code is kind of complicated, but ultimately what this is saying is that if this is logic to say, if we're doing an atomic operation or a transaction, then verify it, but do it in an unsafe way. Again, unsafe being not grabbing any locks, okay? Otherwise, go to the destination first and verify, and then go to the buffer and finish the verification. So when using a buffered store, what we actually have to do is we have to look in both places in order to read data. We have to look first in the destination, which is the database, and we have to look to see if the data is there. Then we have to look in the buffer to see if the data is there based on what the destination tells us. So the first thing we do here is we're going to go into this code path here, destination.verify. I'm just going to set a breakpoint there to make sure we stop there. I'm going to press play, and we end up here. So you can see I'm in the database class in the verify method. And what happens is we make a different representation of the key, and we get the primary record. There are primary records, which is where most reads happen. There are secondary records, which is where all queries happen, and then there are search records, which is where all full text searching happens. But we go to this get primary record method, and I'm going to press play, and we're going to get here. And what this does is for the database stores stuff on disk, and it organizes it and indexes it. When we get the primary record or the secondary record, or whatever the case may be, we actually have to first check if that thing is in memory. So CPPC is the name of a cache. And we check to see if it's in memory. The record is not in memory. So that means that we've got to load it from disk. So we create a stub of the method, and the method is just empty. And then we go through every block that's stored on disk for the database. And you can see for CPB, that's the primary blocks. You can see that we've got a lot of blocks stored on disk because I've got a lot of data that was already stored prior to this exercise. So we're going to have to go through each of those and load up any data that's in the record that we care about. Now, that sounds like a very slow process, but that's very optimized. We use Bloom filters, indices, a lot of different metadata to ensure that we only look at a block if it's possible that data is actually stored in the block, okay? So that's just an iteration and a loop that happens. Once that's done, we have the primary record. And then, so just to go and step out, right, what happened was we called get primary record, okay? And now we're doing a seek. And those seeks are adding data. So I'm gonna temporarily pause that and step back out here. Okay, so we've got our record and we cache it, and then we can go ahead and return it. So now we have an object that refers to the record, and then we're going to call this verify method. Okay, we're going to do that. So I'm going to press play. We've got the primary record we want. You can see that we've got record 17, and it's a partial record, so it's a record 17 with only the foo field in memory. And we're going to call the verify method, okay? So we're, again, some more misdirection. We get a set of parameters. We call another verify method. I'm gonna step into that. And again, it checks to see, is this a historical query? No, it is not. So it's going to call the get method for the primary record. So that method here gets called. And again, we're in the primary record, and we take a read lock on the record so that, again, anyone can read from it, but we prevent anyone from writing to that record while we're trying to process the read. And we get the values that are currently present in memory. So the values that we've actually loaded from disk are placed in this present collection. So you can see all of these, right? I have a lot of data that I've stored for foo in record 17, right? And we also keep track of the history as well. So you can see that's a history of the modifications. All of this was loaded from disk, and now it's in memory. So we get those values and we return them, and then we unlock it, okay? So once we step back up, we will be back in the database. The database can now return, it can now sort of return whether that data exists. So the answer is false because it's not in the list of data that was already on disk. So the first part of that is we have to look in the database to either get the data that we want or check to see if the data exists. The database says no. Value 2000 does not exist for key foo in record 17. So now we have to check the buffer, okay? Because there may have been data that was added to the buffer that is yet to be indexed. So we've got to check that as well. So we go to this method in the buffer. It's actually defined in limbo. That calls another specialized method within the buffer. And what that simply does is it iterates over all the writes in the buffer. So if I look in my buffer, I can see all the pages that exist, right? I've only got one page. And for that one page, this is that one page. I can actually see all the writes. All the writes are just stored as a byte buffer, as a memory map byte buffer. But the data is actually also represented in memory. So you can see I've got a lot of stuff in my buffer as well. I've got a lot of writes that have yet to be indexed, okay? So the buffer actually just iterates through all of those writes. Again, that sounds like a slow and inefficient process, but we use a lot of optimizations, Bloom filters, the inventory, a lot of metadata to ensure that the data that when we iterate, we don't actually look at every write. We only look at writes that are relevant to what we're searching for, okay? So this thing is gonna go through, and you can see that it quickly, like the iterator quickly was able to say, there is no data that's relevant to the write that you're looking for. And that write being this right here, right? There is no data when we want to go and verify it. There is no data that is relevant to the right that we care about. So exists is still false. Step out of that. And that's the verification, okay? And that's an example of a read. A verify is a read. Again, the write path does an implicit read. But since we want to write this data, we want to verify that it doesn't exist. We do that, and then we're now able to insert the data into the buffer. So we call this buffer.insert function. And this is going to lock the structure of the buffer. So what the structure lock does is it just ensures that pages cannot be added or deleted from the buffer while we're inserting data. And so that doesn't prevent reads or writes from happening. It just ensures that the actual structure of the buffer doesn't change while we're doing this, okay? So this notify variable here is just basically a check. Should we notify the engine that the buffer has data that can be transported? In this case, no. The criteria for that is that there has to be at least 2 pages in the buffer, and the amount of data on the current page has to be empty. And then we append the write to the current page in the buffer. So we go into that method, and again, we just do a basic check. We grab a lock, and this content variable here, that's our byte buffer. You can see that we've got a capacity of 8 megabytes. 8 kilobytes. And this is how many kilobytes that we've actually stored. I'm sorry, that's actually just bytes. That's the capacity of bytes that we have. And that's how many bytes we've actually stored on the page. Okay? So we check to see if we've got enough room to accommodate the write. And we do. So we index the write. What happens when we index the write is not indexing in the traditional database sense. We only index it for the buffer, which means that I talked about all the metadata we keep to make the verify, like searching through the buffer, very optimized and very efficient. That's what this indexing does. So it records a lot of metadata about the write itself. It looks at the hash code of the record, the key. It puts them in various caches and Bloom filters to make sure that the next time we want to search through the buffer, that stuff is very efficient. So we do that. And then we actually write the data in the buffer. So this is, you'll notice for the content, we're actually gonna put the size of the buffer of the write, and then we're gonna copy the write. And you'll notice that our position in the underlying byte buffer increased. We're going to add data to the inventory, and then we're going to sync this to disk. The buffer is actually backed by disk for durability. So we're going to fsync this change to disk. And we're done. We don't need to notify anyone. So now we're just going to finish. We're going to notifying about the version change is relevant. If there are any transactions that grab any locks that we grabbed, we're going to tell them that they're invalidated. So we're just going to do a bunch of stuff. I'm just going to press play. And now you'll see, finally, 1,765 seconds later, Concourse shell responds. It responds to say that, yes, I have added foo is 2017. But that's the write path. And we've also looked at the read path that happens as well. The write path, again, we went from Concourse shell, then we hit the Concourse driver, and then that data got transmitted via thrift to Concourse server. Concourse server found the appropriate engine to handle the data, and the engine did a lot of processing. It did an implicit read to check to see that the data doesn't already exist. That implicit read had to check the database first, and then it had to check the buffer. And then once it verified that the data does not exist, it appended that data to the end of the buffer. And eventually that data, as more data is written to Concourse, that data is going to get transported from the buffer to the database. So that's the right path. We're running on time, out of time. I wanted to touch on unit testing, but I can do that maybe in a follow-up blog post or a follow-up session of some sort. I know this was a lot, and I appreciate people kind of hanging around and watching. This session is going to be on YouTube if people want to go through and review it some more. But does anyone have any quick questions about anything that we've gone over? I can answer those quickly. I'm happy to take emails offline if people want to do that, or maybe schedule some time on Skype to chat with people offline if they want to do that as well. But any quick questions before we kind of call this the end of the broadcast? Okay, well, seeing no questions from anyone, if anyone wants to reach out to me individually by email, please do so. Again, I know this is a lot of content, and I don't expect that people kind of watch this session and are now experts on the code base and able to really dive in and just start hacking away at it. But hopefully this at least provided some context on how the different pieces fit together, how data travels from one place to another. I'm happy to host similar sessions. Maybe we can do shorter, more focused sessions on any of these points or other points in the future, whatever people might find helpful. But again, this is going to be on YouTube. Feel free to email me with other questions. I'm happy to continue to provide guidance, whether that's a session like this or writing blog posts or email messages. So again, thank you for watching. Hopefully this was marginally helpful, and I look forward to working with a lot of you all, in the coming weeks and months to contribute and continue to build this out and make this one of the coolest open source projects there is out there. So I'm going to end the broadcast now. Again, thank you.